Here we are, video number 2, how to do period. Please recall from the last video, if you watched it, that a simple sine, y equals sine x, moves from 0 degrees around the entire circle, so 90 degrees, back to 180, comes around to 270, and then back to 360, so it makes a whole circle. But because we're on a graph here, we move sort of forward in time, and so we get to 360 degrees, and we're back at the middle again. And we've gone up once and down once for one cycle, called a period. Now, if you look at the equation, you'll notice that it doesn't seem to have the period in it. It has the amplitude, which is here, There's the amplitude of 1, a height of 1 from the middle. It also has the middle value. The middle value is 0 because that's the middle value there. So there's the amplitude. Now this 360, though, doesn't seem to appear. What you would notice, though, is there is sort of a 1 here, but it's not a period of 1. But if we made that 360, ooh, that's a little bit funny. If we made that 360 divided by 360, that is 1. And there we go. We have the same graph, same everything, and now we have the period included. So the formula is on the board. It's also here. K equals 360 divided by period. Because this is a normal graph, the period is also 360, and so we just make that K 360 over 360. It becomes a 1 and disappears. So that is why these are the same thing, because there's the 1. So if I wanted to change this to, say, now we got to use brackets if we want to do that, and I put a 2 here. Now you'll notice that one cycle takes me 180 degrees, and in fact 2 cycles takes me 360 degrees. And that's very important because there's a 2 here. That basically says that you can fit 2 graphs now in the old 1 graph. So one graph took us 360, one cycle from the old original graph, and now a graph will take us half, and another half makes 2 whole cycles. So if we wanted to write that in the sort of longer way with the 360, you do 360 divided by 180, there we go, x. Our period was 180, so if we put that at the bottom and we do the math, we get a 2, meaning that now we can fit 2 graphs in what we used to be able to fit 1 in. Oh, 2 cycles. I keep saying graphs instead of cycles. So then on the flip side of that, if you wanted to have a period of, say, 720, then you'll notice that it goes and goes and goes all the way up to 720. Let's clear out this little guy and this little guy, make it a little easier to see. So if you look there, in the old period, we've only finished half a period from the new. So predictably enough, I've got to move me here, predictably enough, if you were to do sine of 1/2 x, you get the same 720, because obviously 360 divided by 720 is the same as a half, if you use a calculator to show that. So it takes half the time to get to 360 that the other one took the whole time to get to. So it took a whole time to get to. So that's period. Why does that all work? Well, there's this handy-dandy picture. It's quite a famous one. And in this picture, you can see that here you have a wheel. This is the sine graph. And as it hits the middle, going down to the bottom, back to the middle, up to the top, back to the middle, down to the bottom. So you can see back to the middle, up to the top, back to the middle, down to the bottom. And so as you go around in a circle, because these are circle graphs essentially, you're creating different heights, getting taller, back to the middle, getting lower, back to the middle. It goes from max to min to max to min and back. Cosine, if you notice up here they've got cosine. Cosine actually works somewhat oppositely. You can see that it's sort of been offset a little bit. Cosine is sort of the opposite of sine. It's a little more complex, but thankfully you don't really have to deal with cosine, so don't worry about it too much. So there you go. So if we go back to our classwork, and if you looked, I've now added the first video, and if you look at the questions, question number 5, so you're doing question number 5, and you notice that you've got these two here, and I've thrown the period formula there. So if I wanted to do amplitude, I don't even need a graph to do amplitude. I know that it's 2. If I want to do period, I don't even need a graph. It's right here, and it's 360, because 360 divided by 360 would give me the 1 that is sort of invisibly sitting there. And then finally the axis of symmetry, which is a fancy word for the middle, is 3. It's right there. That's just the middle value. And so I also could say that the maximum, you don't have to say this in this question, is 5, and the minimum is 1. Okay, now I can come across to this guy here. Amplitude is here at the front, so it's an invisible 1. The period now is a little bit trickier because it says 2. I have to work out this formula down here. So I would say K equals, well, K is 2, because it says so right there, equals 360 divided by period. Now the nice thing is that this can just switch with this, so I can say that period equals 360 divided by 2. They can literally switch spots, and that equals 180. It's half a circle. A triangle is half a square. A triangle also has 180 degrees because a square has 360 degrees. So anyways, long story short, 180. And finally, the axis is -1. Be careful with that negative. So that is how you do period, and that is what you would have. Please make sure that you're actually making pictures of your graphs. Sorry, my apologies. So you can just X all these out. Do have pictures of your graph. What is it? 2 sine x plus 3, and y equals sine 2x, 2x minus 1, and then you can see that, you know, take a quick picture of this. If you wanted to take a picture of it where you have some of the important points thrown in, you could click on some of those points. That's not an important point. And if you wanted to see the middle, you need to do that so you can actually click the middle to see the period. And if you want to see the period of the other one, you have to do that so that you can see the period. Okay, that's it. That's what you do. Add the picture to the other, and you're good to go. All right.